Hey everybody, it's Ben here from Ambionics. Welcome to the final installment of how to design your own prosthetics. Today I'm going to be showing you how to complete the process by marrying up the socket that you've designed with one of the products that we offer on our free store. So go to payhip.com /Ambionics, and at the store you'll find a range of products that will marry up with the lofted socket that we're going to do now. So you can either pick the split hook, which is much more functional for adult use, or something cosmetic for kids with limited passive function, and that's the one that we're going to run with today. So we've got the Ambionics original. Download it as an F3D file and then just bring that into Fusion 360. So the first thing we need to do is align it and mirror it if necessary. Now I always make arms for Sol, he's left-handed, you might need a right-handed socket. So in order to do that, just quickly mirror it. So bring up the origin, offset a plane that's some distance away from the object, and then you just come up here and create mirror. Select the component that you want and then the mirror plane. So that works for the split hook equally, and there we have it. So that would give you the mirrored version. We're working with the left one today, so that's the one we're going to proceed with. What we need to do now is to align it. It comes in basically as if it was on a 3D print bed. What we need to do now is turn it upside down for the modeling. So select the component, hit M for move, and then just turn it through 180 degrees. And I like to bring it down so that the tip of the thumb is on the ground plane. And that will be obvious why I'm doing that in a moment. Roughly there. That's about right. Okay. Once we've done that, we bring in the target geometry from the socket that we've already modeled. So you might have taken a cast or done a 3D scan and then followed the process to create a socket like this. So here's one. This is actually the socket that Sol's wearing today. He uses a completely different system, so I use the PVC tubing. But for today's purposes, we're going to use the socket geometry. So take the 2D surface that you created, copy it, come back to the folder that you've just opened, and this is important. So right click on the top and select do not capture design history, click OK, create a new component, doesn't matter what you call it, and then right click on it and paste the geometry that you want. OK, and then go back to the parent component and capture design history. So now everything we're going to be doing is going to be parametrically modeled. Right, so we've got our socket. It's not quite lined up yet, so let's do that next. So we pick the component, hit M again, and just roughly center it above the hand. Looking from the front view, you want to center it so that the apex or the bottom of the curve for the socket geometry is somewhere lined up over the release button, about there. Okay. Next, what we need to do is create an offset plane to give the distance from the crease of the elbow. So Sol has a very short below elbow amputation, but he does have a crease, and that's the point where the anterior trim line on the socket goes. So that needs to be in the corrected state. So we'll pick the model again, hit M one more time, and I rotate my sockets around about 25 to 30 degrees. So what this will do is give a more relaxed position when it's being worn. The arm would never be 180 degrees. Nobody walks around with their arm completely straight. It should be roughly anywhere between 20 and 30 degrees to be comfortable. And also, do I need to change the alignment at the front? Yes, I do. So I need to just swivel that around. So undo that step. So I want to bring my about 10 degrees that way. Okay, and then 10 degrees, 30 degrees that way. Pick the component, M. 30 degrees, there we go. Okay, so now select the parent body again, and we're going to create a construction plane, taking the ground plane from the origin, offset it, yeah, we'll capture that position, and then we're going to put it to the position where the trim line should be, so that's 230 millimeters. Now I take my socket, hit M again, pivot point, select this inner circle here. That will give me a nice flat edge to lift off, and then bring it up so the trim line is touching right, yeah, around about there, a little bit lower. Now 5mm is actually noticeable, people, so try and get it dead on. So that's about right there then. So yeah, that intersects with the right place. Okay, so we have the socket lined up. Now we need to line up the hand as well. So in this position, the hand would be dead straight, like it's reaching out to hold a cup of tea. What we want it to do is be a more relaxed, natural position by turning the hand in slightly. So pick up the hand, hit M again, and then we're going to select that same pivot point so that we rotate it through its own center. Hit the green tick, and then I think about 15 degrees should be enough. And that'll give us a nice, relaxed, natural posture. So let's crack on to actually making the socket itself then. Now we want to highlight the component, our body surface, and then we go to create, thicken, and I've put that in my shortcut menu up here. Capture the position, and it's already done it. If I was printing this in a test socket, then a couple of walls thick and 1.8mm is fine for confirming fitness. To make something rugged enough and durable enough for everyday life, I like to make it 4.2mm if I'm using ColorFab Vario Shore. There are other TPEs that you can use. Again, something chunky like 4.2mm will be perfect. The socket body itself can be a little bit thinner because it's tubular and it actually has some rigidity in it. So we're going to OK that, 4.2mm. That's going to give us our Vario Shore socket at the top. That's all done. Just to make things easier from this step, I'm going to change the visual style to include visible edges. And now you can see what I'm doing a little bit more clearly. So what we next need to do, turn that plane off, and we're going to take a profile from the socket to create the top of our loft. So just zoom out slightly, pick up this plane on the origin from the side view, create a sketch, and just any old way, just somewhere around about the anterior line to somewhere at the back of the socket, create a single line, finish that, that's okay. Now we need to construct a plane. So we could plane at an angle, and this will bring it in the sagittal plane, but we want to just change that by hitting 90, and that gives us the plane that we're going to take a profile cut through this socket. So we can go back and turn off that sketch, create a new sketch, and we're going to hit intersect. Once more, it's on my shortcut menu. You can get it from down, project, include, intersect. So hit intersect, make sure it's set to bodies and not specified entities. Hit the body with a projection link, include that. And that gives us two profiles, the inside and the outside, which are 4.2mm distal from each other. Select the inside one and just delete it, we have no need for it. And finish the sketch and turn off that component. Oh no, yeah, we don't need that one anymore. Turn off that body as well. Second up, we need to take a profile from the top of the wrist adapter. So this is going to be permanently screwed. So if you look at this, the hand itself, turn all those off. So this is the part we're interested in. This is the adapter. I print this in TPU, I've molded them, I've tried more rigid plastics, and I can say that TPU is best. TPU will, in the event of a severe bang, will allow it to fail safely, so you'll be able to just pop it back on again. So printing this in TPU, this is the adapter plate that mechanically fits to the bottom of the socket. We need to right click on its surface and offset a plane, and then create a sketch on that plane, and we're just going to capture the outer edge. So just this outer edge for now. It's done that. Now we can turn off that body and we have our two lofting planes. Finish the sketch. Okay. Next up, we need to create a loft. So it's create loft. Pick the top profile, pick the bottom profile, and just OK that. Select the top face of the profile and then go to modify and shell. And this should be, the walls of this should be 3.5mm thick. and that will have a closed end at the bottom, so select the closed end and delete that. That will now give you a tubular structure. Let's bring our socket body back. We can see there that that line bears no relationship. So we'll bring our first sketch up, and the great thing about Fusion is we can now modify this and get the shape that we want. What I want to do is make it as printable as possible, so I don't want any steep overhangs, so I want to come just underneath this lip, and I want to have a nice natural shape. Ooh, that one didn't work. So that wouldn't print very pretty. That comes in too close. How about down that way? You can just play around with it. That looks pretty clean. Later on we're going to apply a fillet to that line, so you don't want it to be too convoluted and running around all over the place. That looks like a nice socket shape to me. So we'll OK that. And again, you can play around with it later. The next step is to join these two together. So we need to do a cut and combine. So pick combine. We're going to cut the bottom piece with the top piece. Select cut. Keep the tools. OK that. That might introduce an additional piece of unnecessary material. We're lucky in this case it didn't. So otherwise you might need to, if there's anything left over, just highlight it and click remove from there. Now that we've done that, we're going to join these two pieces together. So again, pick both sides. This time it's not a cut operation and we don't need to keep the tools. So that's our basic socket shape. Close that off and bring open the hand again. We've already created a plane, so just reuse that, create a fresh sketch, and there are 2 points of interest that we want to pick up here, which is the inner diameter of one of these screw holes. So press P to project, pick the inside edge, that should be 3.5 millimeters, and press Control and select the other one as well, which is the internal axis. Should have both of those. Turn that off. Yeah, we have. Now what we're going to do is create a rib using this screw hole, so it needs to be fairly substantial. So what I'm going to do is offset from that 2.5 millimeters, which gives me a circle of 8.5 millimeters. Now we need to connect the centers of these two circles here using a straight line, and this will give us the angle that we need to send the ribs into the socket. Press L again to connect another line, and then just play around with it until you get the collinearity sign. So we know now that that's one continuous straight line. Hit the line that we've just made, press O to offset it, and then type in those measurements, which was 8.5 millimeters divided by 2. So we've now got a tangent line on the one side. Close that off by mirroring, and then connect up the ends so that we can extrude this geometry. There we go. Finally, just turn that into a construction line. Okay, so we view the sketch. We're now going to extrude this upwards so that it's much taller than the socket. So a nice number for me, knowing that it's 230 mil, is extruding at 300 millimeters. Make sure that you picked up both of those profiles, and then just manually enter in 300 millimeters. Now the sketch that we were just working on will disappear by default when you finish that operation, so just bring it back open again. Now we're going to go to create circular pattern. So in the menu, that's down to pattern, circular pattern. We select this body and tell it to use the axis that we picked up from the center. I think it will usually default to 3 pieces. Make sure the quantity is 4, and that's how the adapter was modeled, so they should pick up perfectly. We now have what will become the 4 ribs to reinforce the inside of the socket. Next, highlight the top of one of these, create a sketch. This is just a tool body. We don't need to use a plane, and just a circle that's just, as long as it covers them all. Pick up all of those profiles, hit E to extrude. 1 millimeter is absolutely fine, it just needs to be a physical object. We now have our rib cutting tool. From there, bring open the body again of the socket, and we're going to cut the rib cutting tool with the socket that we've just designed. Make sure you keep the bodies on, and OK. Highlight the top face of the rib cutting tool and hit V to make it disappear. And what we want to do now is get rid of everything that is not a rib. So by a rib I mean one of these 4 bodies that are left over. So we know that that is removable. That's one of our ribs. So we're going to keep that. We're going to keep that. Keep that. That's not a rib, so we can remove that. That's actually in the top of the socket. There are two pieces there, you can see. So we'll right click and remove. Don't delete, just click remove. Then there's this other one here. Again, remove, just keep the workflow nice and tidy. So now everything here is either a rib or a socket. Final step then, as you might have already predicted, is to join all of those together. So we just select the socket and hit join. We don't need to keep any of the tools, and just manually pick up each one of those. You'll see when it's selected because deselect it. You lose this line here and you can see that it's continuous then. So it says we've got 4 bodies. So we've got 1 target body and 4 ribs selected. Let's just get rid of that sketch, and then we can see that they've all done nicely. It will print quite well like that. You have to have some support material on the inside, which can be removed away later. I found that with Colorfab VarioSure, that's absolutely fine. If you wanted to, you can create a flattened surface here. So to give you something better to work off. So offset the plane. Just to give you a contact patch there. Create sketch. Just have a circle. There. Extrude that down. Yeah, it's not interfering with the inside. So we've still got our socket geometry on the inside, and now we have an additional bit of material that can be printed up to. So while this is printing, the socket in VarioSure of this size would take about 13 hours using a 0.4mm nozzle. So be prepared for a long print. We don't want anything to go wrong, so it's best to take these steps now. Final steps then, we've got a 4.2mm thick socket at the top, so we can easily afford a 3mm fillet so that the upper trim line rolls away from the body. Click OK on that, and then 1mm will be fine for the edge. I like to put a large fillet on this joining line. So I'm just going to adjust this slightly more, and we've got a bit of a convoluted line along here, but I think that should be fine. So select the 2 areas. F to fillet, select those 2 areas, and then I'm going to try, no, how much can I get away with? 13mm is fine. Hope you've enjoyed this video, and in fact this series. If you have learned something, put it in the comments. If you have any questions, likewise, make sure you hit the like and subscribe buttons. It does help our channel to grow. We're at 870 subs at the minute, and we're trying to get to 1,000. So stay tuned for future content. Take care, guys. Bye.